Okay, welcome to the last lecture. Okay, the last lecture for the aromatics, ingredient and flavor applications. Okay, for the chapter 8, we're going to talk about dynamic of flavors compound release during food mastication. Okay, food mastication means, for example, like chewing and breaking out the food before you swallow. All right. So the examples we're going to give today for this chapter 8 is the cheese and candies here. The candies that are made of gelatin. Okay, so we're gonna use the cheese and the candies as examples. Alright, let's look at the first one here, which is the cheese. Alright, right before we talk about the mastication of cheese and the flavor release, you must realize that the aroma compounds, they are released during food consumption in the case we are chewing it, and then transfer to the flavors component will be transferred to the olfactory receptors in order to be perceived. So imagine that you just only eaten, okay, so over here you can see the food has been eaten. So when it's in the mouth here, of course it will be a taste. Okay, it will give you the taste based on the tongue as well. And while you are chewing the food, okay, you are actually breaking the structure of the food. Okay, so it will release. Okay, during the breakdown of the structure of the food, it will then release the aroma compounds, and you can either most likely you will be perceive, have the smell through the retronasal olfactions here. Okay. So it really depends here. So the food, how it releases the flavors from the food, it really depends on the composition. Okay, so it depends on the composition as well as another thing is the microstructure of the food. Okay, composition is, for example, like what is it composed of? Is it high fat? Is it low fat? Okay, is it high in proteins? Is it low in proteins? Okay, is it high in carbohydrate, low in carbohydrates? And you also based on what kind of carbohydrates, what kind of fats, what kind of the proteins, and how they actually compose the microstructure in terms, is it like a network? Okay, is it like a globule? Okay, so what is it? How is it the structure? Because all this structure and the compositions will affect how the flavor is being released during mastication. Okay, later I will give you some examples that will give you some idea how it can affect the flavor release. Because conventionally what happens is that people say, I will just add, okay, I want to have banana flavor, butter flavor and so forth, so I just add inside, okay, and the food, alright, then I just made it and people chew it, I can taste all of them. You will realize that, how come I can taste certain thing, but sometimes my formulation, even though I add a lot, but it doesn't taste. What is the reason? Okay, sometimes you will be thinking as well, how come I added all these three? How come they give at a different time of period? For example, maybe I would be tasted this flavor first, then only this flavor. That's actually it may have a sequence of the flavor release. Okay, later I will show you a video as well. No, the video link. I will show you the video link, and you can watch as well. Yeah, how they explain about the flavor is being released here. Okay, so very important. Make sure that you understand that the flavor release depends on the compositions as well as the microstructure. Yeah, so the examples that I'll be giving you later on, okay, the two example cheese and the candies, it will give you some ideas. Okay, influence aroma release and perceptions by product composition and nature of the aroma compounds. Okay, very important as well. The aroma compound, is it hydrophilic? Okay, is it hydrophobic? Okay, and so forth. Is it contain charge or so forth? Yeah, all these are very important here. Physiological parameter and chewing behavior. Okay, so is the person going to chew very hard? Is it going to chew hard very long as well, because the food is a bit hard, so you need to chew longer a bit? okay, and compared to those food that you only require to chew for a while and it can straight away swallow, okay, the release of the flavor profile is very different. Yeah. So we have covered the cheese production, the pipeline. Okay, so what comes first? What happens next? Okay, so usually the milk, okay, will be coagulated. Okay, after coagulated, then it will form what we call curds. Okay, the whey will be drained away. So the curd will be used either through making fresh cheese, or maybe they will be aged to form what we call a ripened cheese. Yeah, so it really depends. And for the low-fat milk, usually what happens is that, low-fat cheese, usually what happens is that they will use low-fat milk. Okay, so they will start with low-fat milk, and then the cheese production is more or less similar. Yeah, but it depends. Okay, depends. So let's look at this here. The following two examples, next two slides, is basically talking about the differences between the reduced fat and the full fat cheese here. So looking at this, in vivo aroma release was highly dependent on the texture and composition of the cheeses here. Reduced fat cheese has different melting characteristics than regular cheese. It takes longer to melt. It may be tougher as well. Usually when you're talking about reduced fat cheese, you can see that they are usually harder. Okay, usually they are harder, which means that the person who eats it, they require to chew harder, longer and harder as well. Okay, stronger and longer as well to chew the cheese here before it's being tasted. Okay, because of the high melting point as well, it doesn't melts in your mouth, so you require to chew longer a bit. Yeah. So because of this chewing activity, which is more intense, what happens is that this will induce a greater food breakdown in the mouth and a higher in vivo release of the nano 2-1, the blue cheese flavor. Yeah, again, nano 2-1 is basically the blue cheese flavor. So as you chew longer, the chewing will facilitate the release of the flavor from the cheese, from the hard cheese, and this flavor, right, then will be transferred through your nasal, okay, olfactions, and then you're going to perceive the flavor. That's why the chewing is actually helps the flavor release. Because if you compare to those that is do not require chewing, what happens is that they straight away swallow. When they swallow, what happens? They cannot actually go through the nasal. Yeah, okay. So that is the difference. Comparing with the high-fat cheese, okay. High-fat cheese, right, what happens is that the nano 2-1, okay, nano 2-1, which is the blue cheese flavor, by nature itself, this flavor molecule is hydrophobic. Okay, because it's hydrophobic, so it's going to bind to fat. So when you're talking about high-fat cheeses, they're going to bind more to the fat, making it less available to be released to the nasal pathway. Yeah. Okay, so you can see from here, this flavor, okay, will bound to the fats, okay, and is not available to be perceived, okay, through the nasal olfactions. Yeah. Whereas if you compare to the ethyl propanoate is more or less is a hydrophilic. Yeah. Okay, because it's carboxylic group over here. So it was released more from the high-fat cheeses, and so you can perceive more. That's why sometimes the fruity cheese, okay, you can taste a lot of the fruity flavors, okay, and it can actually use in the high-fat cheese as well. Yeah, in this kind of products. So high-fat cheese, then you incorporate some of the fruity flavors or whatever, okay, then you can eat it, okay, perceive very strong fruity taste of the cheese. Yeah. Okay, there are market, they have this kind of cheese here. Okay, so here demonstrated by chewing the hardness of the cheese, okay, which actually promote you to chew harder. When you chew harder, then the flavor will release more, okay, and you can perceive it. All right. Another case that we talk about is the molecule. When the molecule is more hydrophobic, what happens is that they bind more to the fat component. If it's high fat, it bind, they got more fat to be bound. So what happens is that it's not available to be released into your perception there, yeah, to be perceived. Alright. So choosing the molecule and looking at the food composition and the microstructure is very important here. Okay, the next one that I want to use it as the example is candies. Okay, in these studies, right, what happened is that they use different percentage of gelatin, okay, to use it to modify the candy. Yeah. Of course, 0% one is going to be very, very soft. Okay, it's more like a liquid. Of course, it won't be in this the form of gel. Okay, this one is for illustration purposes only. And then when you add 2% of the gelatin, it will be slightly harder. 5% it will be even harder. 15% it will be even harder. So what happened is that these four formulations, all of them contain the same composition: glucose syrups, sucrose, citric acid, and red dye. Okay, all of them is constant for four of them. Okay, all of them are red, supposedly red color. This one is for illustration purpose only. And all the product, they have the same concentration of the three flavors: diacetyl, the butter flavor; ethyl hexanoate, which is strawberry flavor; and the hex 3-in-1-0, which is the like the green vegetable type of the smell. Yeah. Okay, so I need to reiterate that other than the percentage of gelatin concentration is different, all the others are constant. Yeah, the concentration of all these, the syrup, the sucrose, all same, and then the flavor component is also same in all the examples over here. Yeah. Okay, so you will most likely perceive that for 0% it will be very, very fluid. Okay, more or less when you consume, you straight away will be swallowed. When it's 2%, okay, you require a certain amount of chewing, but very quickly you will swallow it. This one, 5% and 50% especially, you require to chew longer a bit. Okay, when you chew longer a bit, then what happens before you swallow? Yeah. Okay, so what happens is that you can see from here that 0 to 15%, they will have a different resident time in your mouth, which means that the total time in your mouth, okay, chewing will be different. Shorter time in your mouth and towards the longer time in the mouth here. So you will perceive that this one, okay, very fast you swallow, okay, the flavor very sometimes not even have enough time to be perceived, then you swallow already. Whereas this 15% or higher percentage of gelatin, which requires some mastication, it will be in your mouth longer, the flavor will be released, and then it can be perceived here. Okay, so next time when you make candies, this is very, very important. The amount of gelatins actually dictates how long it's going to be in your mouth. That's why for chewing gum is like always chew. The more you chew, they keep on release the flavor into the nasal through the retronasal path here, so you can actually taste the aroma longer a bit while you are chewing the chewing gum. Yeah. Okay, let's look at what is the difference here. So over here, what they found, right, is that looking at the 0% gelatin, the strawberry flavor was the only one that is tasted. The other two flavors, the green and the butter flavor, they cannot perceive. So what happened, right, is that because of the very short resident time, and the flavor, the strawberry flavor and the other flavor is not really trapped in the candies, but because of the short resident time and the strawberry flavor can be captured before it's being swallowed. All the others, which is the green and the butter flavor, right, not even be able to capture, then they already swallow already. Okay, so probably because of the early release of the ethyl hexanoate, strawberry, and the very short product resident time in mouth before green flavor can be released here. So you can see from here, they can taste only strawberry if it's very, very low in gelatin here, because the strawberry flavor can be perceived earlier, can be detected faster. Probably it got to do with the flavor molecule properties here. Whereas if you increase a bit of the gelatin to 2%, okay, because of the slightly longer of the resident time in your mouth, they can actually start to detect the green flavor first before the strawberry. Okay, when you give enough more time in the mouth, okay, then the green can be perceived first before the strawberry. However, because the green may be overpowered compared to strawberry. Okay, even though the green may be slower, but if you give enough time, then they can overpower the your perceptions. If you're looking at these 5% and 15%, you can see from here that 5% and 15%, you can start to perceive the butter flavor. Okay. Yeah, so as you chew a bit longer okay, and allow the candy to be in your mouth longer a bit, when you slowly release all the flavors all in your mouth, then the butter flavor will overpower the green and the strawberry flavors. So you actually can taste the butter flavor first before the green and the strawberry flavors. Okay, so you can see from here, it's a very, very useful insight that even though the three flavors have the same concentration, alright, what happened is that by differing in the amount of gelatin in there, which resulted in the resident time in your mouth slightly longer, okay, as you chew more before you swallow, the flavors can go from reverse. They can actually detect the butter flavor first before the green and the strawberry flavor. But if you do not have enough of resident time in your mouth, okay, do not even chew it, they actually can detect the strawberry flavor first. So you can see from here, the gelatin also will change the sequence or detection of all these flavor molecule. Okay. Alright, so next time, don't assume that I put all these three flavors in there and I can perceive all of them. It really depends on the compositions, how long it's in your mouth, and also the property of the flavor molecule. Okay. So the flavor resist in candies, flavor resist shifted from strawberry to green to butter when the gelatin percentage increase in the formulation. Okay. Okay, so I hope these two of the examples will illustrate the importance of the compositions as well as the microstructure of the food products that will changes the mastication's property, okay, and the resulting flavor release as well as the perception of the flavor in the food products. Okay, I will give you a link, okay, in the Times. Okay, please view it. All right, it got some insight into how the flavor, sometimes they can see they can detect some certain flavor first before another flavor. All this got to do with how they actually design the flavors, how they combine the flavors into the product as well. Okay, if you got question, please ask in the palette. If you do not have question, please indicate no question in the palette for attendance purpose. Alright, thank you so much.